Hi everyone, welcome to another maths video by Maths with Sarah. So this question is taken from Edexcel exam paper. It's from November of 2018 and it's a higher paper 2, so you can definitely use a calculator. And this is question 14. Now this paper was given to one of my maths groups, and some of the girls in particular were struggling with this question, along with some of the other harder ones as well. So this is why I've done this video specifically for them this weekend. So this question 14, on the grid, we've been asked to sketch the curve with the equation y is equal to 2 to the power of x and give the coordinates of any points of intersection with the axes. So this is going to come in quite important later on. So points of intersection with the y-axis and or the x-axis. So some of you might be able to draw this graph straight off, or at least have a good idea of what it looks like, and definitely be able to tell us kind of where the points of intersection are. There might be others of you where you're looking at this just going, I don't even know where to start. So I'm going to start with the very basics. We're going to go back to kind of when you're drawing linear graphs or any sort of quadratic graph, and you're always told, okay, right, let's put in some values for x, put in some values for y. We're going right back to the basics, and that's going to give us some idea of what this graph is going to look like. You don't have to remember anything, you don't have to know anything, you can literally just work out each of the values. Okay, so I'm going to draw myself a little table. I'm not going to do too many values. So I'm going to start with -3, -2, -1, 0, 1, 2, 3. Now, you're obviously going to notice that this graph does not have any values on the x or the y-axis. There's no scale, no idea how big or small this is going to be. And to be honest, we're not going to need them. We're just literally potentially just using it as some idea of what this graph is going to look like. Again, you don't need to give any specific points other than where it crosses the axis. Like they've not asked you to label the axis, you don't need to. But we're just going to use it just for the purposes of working out what's going on. So to work out this y value, when x is equal to -3, we're going to do y is equal to 2 to the power of x, or 2 to the power of -3. Okay, so hopefully you're all aware that 2 to the power of 3 would be 8. But how does that change when we've got this minus in front of it? So a minus, if we've got a negative indice or a minus power, we write that as 1 over, and this would be the same as 2 to the power of 3. So rather than this being 2 to the power of -3, we can write this as 1 over 2 to the power of 3. As I said, hopefully you're all aware that 2 to the power of 3 is 2 times 2 times 2, which is 8. So we can write this as 1 over 8. So here we've got 1/8. Obviously, you could turn this into a decimal and say that it's 0.125, but we don't need to. We can just leave it as a fraction for now, and that's absolutely fine. So now I'm going to move on to the next part of this. I'm now going to look at y is equal to -2 to the power of, is 2 to the power of -2. So again, we're going to do exactly the same process. Because it's a minus, that means that we've got 1 over. So it's minus turned into 1 over, and then we write the rest of it as it was, 1 over 2 to the power of 2, which is the same as 1 over 4. Again, you could write this as a decimal, but I'm quite happy leaving it as a fraction. I'm going to go on to the next one. Hopefully you're starting to see what the pattern is here. So we've got 2 to the power of -1, which is the same as 1 over 2 to the power of 1. 2 to the power of 1, remember, is just 2. So this is the same as 1/2, or 0.5. Okay, the next one is the one that I think most people will find, it'll be the one that most people get thrown by. Okay, this one here, we've got 2 to the power of 0. Now remember, 2 to the power of 0, or anything to the power of 0, is always 1. So this is our value here. Nothing too complicated about it. Literally all we're doing is we're saying that we've got 2 to the power of 0, which is 1. Okay, then the next one, we've got 2 to the power of 1. 2 to the power of 1 is just the number itself. So 2 to the power of 1 would just be 2. 2 to the power of 2, hopefully you're all familiar with this, just 2 squared. And then we've got 2 cubed, or 2 to the power of 3, which is 8. So hopefully what you're noticing here is we start with very, very small. So the whole of the graph is going to be kind of on the positive axis. We're not going to have anything underneath here. We're going to start very, very small, close to the x-axis. but we are not going to touch the x-axis. No matter what value you put in here, even if you did x to the power of minus 100, it would still be positive. It would not be 0. We would not be touching the x-axis. So we're going to be starting very, very close to the x-axis. We're going to gradually be getting higher and higher and higher. We're going to cross the x-axis at the value x equals 1, and then it's going to get very, very quickly much, much higher. So this point here where we're crossing the y-axis is the point where x equals 0. So the coordinates of this point here would be x equals 0 and y equals 1. And this is true for any graph where we've got something to the power of x, assuming that we're not then multiplying it or adding anything to it, it's always going to cross the y-axis at the value 0, 1. And it is not going to cross the x-axis. You notice here we've got what's called an asymptote. It comes very, very, very close to the x-axis, but it never actually touches it. No matter what value we get, we're never going to get a negative value. We're never going to get this equaling 0. Yeah. So hopefully that's cleared things up about this graph. It's quite a common shape of graph, so it's probably one that you might come across quite a lot, so you probably end up remembering it if you do enough of these practice questions. It's a good one to remember that, if you do get stuck, you can always draw out a table of values. I know they've not given you any values to work with, but you can always put in your own, yeah? And if you wanted to, you could use different values. Obviously, I've used -3, -2, -1, etc. You could use other values. You could go up in 5s or 10s or whatever you find easiest. Okay, thank you very much for watching. Again, appreciate if you like and subscribe to the video and the channel.